Hello.
Hiya.
We're talking about our new narrowboat. The reason being that we've only got about 2 weeks left on this current boat before we hand it over to the new owner.
As you can see, we've done a load of packing.
We've packed 2 books. We've got 2 weeks left to get the packing done, but it's difficult on a boat, isn't it? Because you can't put everything in boxes and put it in a spare bedroom like you do in a house.
Yeah, it is difficult. We need to still live on the boat during that period, but we need to make a start. I think later on this evening we're going to start packing up.
I know. Well, we've got a few things to tell you. First of all, everyone's been asking us, is the new boat going to be called Morning Star? And it's not, is it?
No, absolutely not. I think we've done with that, haven't we now?
Yeah.
It was a fabulous name, and there was personal reasons behind it. However, the new name is even more personal. So a few Christmases ago, Paul bought me a present, and he named a star after our last dog, Dexter. So we decided we'd come up with a few names. They're a bit naff, weren't they? But we took the star from our current boat and decided our new boat we're going to incorporate Dexter into it as well. So the new boat's going to be called Dexter's Star.
Yeah, we just think that's got a nice ring to it, and it's a nice nod to the memory of Dexter. And we know we've got Sebastian with us as well. I'm sure he doesn't mind, do you, mate? So yeah, there is a star. It's in the plough if you're interested, which is, what's its official name?
Oh, Ursula Major.
I think it is. Yes. Yeah. So
I'm not Brian Cox.
no, Dexter Star is within that constellation. So we thought that'd be a nice thing. Dexter Star's got a nice ring to it, hasn't it? Yeah. Now, just before Christmas, we went over to Gateshead in the northeast of England to visit Voltsport, and we met the team there, and we saw basically what is the heart of our boat.
We were basically going over to discuss the components that Voltsport are going to provide for the new boats, which essentially are, it's the motor with its relevant controller, and they're also building their own batteries as well. The batteries are incredible. They've got like real safety features, not just like the electrical safety features, but also some mechanical ones as well.
Yeah, there's even a heated pad to keep the batteries warm, isn't there, to keep them above a certain temperature?
Yeah, because lithium charges petrol like when it's warm.
Yeah, and we want to dispel some of the myths that were out there last year to do with lithium batteries. And you may know there was an explosion on an electric narrowboat. It was a hire boat. Luckily, nobody was injured. But there's a vlogger that's saying, oh, I would never moor next to an electric narrowboat. It's not the fact that the boat was electric that it was dangerous, was it?
No, 100% not. And it was really irresponsible sort of vlogging, I think, because it was to do with the lithium batteries. However, they didn't go into why the lithium batteries had this thermal runway. Generally, lithium batteries are the lithium iron phosphate batteries, or LiFePO, are considered to be quite safe. There was none of that mentioned, and our batteries themselves have that extra, like I said, safety feature where it has a mechanical disconnection as well. So, and a lot of diesel boats have lithium batteries, so it wasn't the fact that it was an electric boat. It was. I thought it was quite irresponsible to say that, to be fair.
But we spoke to the CEO, who is Phil Eagleton. You're impressed that I remembered that?
Yeah. Although I have just read it 2 seconds ago, so I'm a bit concerned.
5 minutes ago, my memory's not that great. But Phil and Chris and the whole team at Voltsport, really nice team of people, weren't they? They really looked after us. Lots of coffee was consumed. And we took in a lot of technical information, which is my forte. I love all that kind of thing. I do find it fascinating. I've just not got the best memory.
Our boat builders were there as well, so the guys from Elton Moss and the guys from Ortomarine were also there. And Rob has been drafted in for the sort of electrical technical aspects, so we'll be speaking to Rob as well during this vlog. One of the biggest one of the things that I was really excited about, but I'm not even sure we filmed it, is they actually electrify classic cars as well.
Oh yes.
And spookily enough, one of the things I said was it'd be amazing if you could electrify a smart roadster, which I used to have years ago, and there was one next door. I don't think we filmed it though, did we?
We did, yeah.
Oh, did we?
Yeah,
it was one of my favourite cars I've ever had.
I love driving that car as well. It was nice, wasn't it? Right, so are you ready for some technical information? We know some people will love this, and our friend Caroline will probably fall asleep at this point from one day more, because she loves talking about batteries, doesn't she?
So, starting off with the batteries, we're getting 4 Evolution 48 volt, 230 amp hour LiFePO batteries. So that equates to roughly about 920 amp hours.
Or 44 kilowatt capacity. Is that right? Kilowatt hour capacity.
Yeah.
Yes. The motor. Can I talk about the motor?
If you like.
Yeah, it's an Enduro motor, and it's a 205 watt Voltsport, call it the DD10 Plus. It's got a 14 kilowatt nominal and 24 kilowatt maximum drive.
It's got a drive kit, like a Sevcom panel on the side. It's pretty much like our current motor, but it's going to be a little bit more powerful.
Yes. And yeah, the drive controller. I want to say this, I'm dying to say this because it sounds like something off Star Trek or Star Wars. It's a Sevcom Gen 4, size 6.
He's not doing
it. But we're going to put all this information up on the screen as well.
Nor have I. And I'm going to get told off by Rob by saying power. The actual major importance of the motor is its ability to drive the propeller, so its torque value.
Yes. I was just going to say that. And actually, we talked to Phil about that as well, and he goes into that, doesn't he? The inverter is a Victon Quattro, 10 kVA. Rob said, don't state kilowatts.
But I think the problem is most people know inverters in kilowatts.
Yeah.
So our current inverter is 15 kilowatt, and this is the equivalent of roughly about 8 kilowatts.
Yes. So, which gives you a continuous 230 volt AC power and 140 amps of DC charging. Did I say that right?
Yeah, that's correct.
Right, okay. So bow thruster.
Interestingly, we're not getting a stern thruster on the new boats. It was more of a cost thing, to be honest, as well, and the room to put the tubes in, because the engine bay is going to be quite full, is it? So we're getting a bow thruster, but we're also getting a remote control, so we can operate the motor and the bow thruster, enabling us to go into locks and use like swing bridges solo using a remote control.
Yeah, swing bridges and lift bridges, I think, is a bit of time we use it the most, really, the remote, won't it?
So this is going to be made up of a Mont Energy motor and again a Sevcom Gen 4 size 2 controller.
So the generator is a Kohler 9 kilowatt 230 volt AC genset, and Kohler have now been rebranded as Relco.
Yeah, the actual generator, unlike ours, which is currently a water-cooled generator, is a raw water-cooled generator, is going to be a keel tank cooled.
Yes. Solar.
So I'm really excited about this actually, because we're also getting rigid panels this time. So although they don't look aesthetically pleasing as the bonded ones, these are going to be tiltable. They're also bifacial, which means we're going to have a light coloured roof, and the incident ray from the solar which will hit the panel will also be getting some sort of rays coming off from the roof that are bounced underneath and collected from the back of the solar panel. They're tiltable, so we can maximise the direction of incident ray from the sun. These are going to be sharp, bifacial, rigid panels. And
we're getting a total of 2.34 kilowatts, which is amazing, isn't it?
That's going to be incredible, and I'm hoping to see a significant reduction in generator use.
Yes, yeah. And that's all supplied by Photonic Universe. Yes, and as you can see, Sebastian's really enjoying this chat as well, aren't you, Sebastian?
You fell asleep yet, mate?
So, yeah, that's all the technical stuff, which is basically the heart of the Narrowboat. And we're so pleased and we were so happy we went over to Voltsport and saw all the systems set up, and the little control panel says Dexter Star. It just feels like the heart of the new boat, doesn't it?
It was very reassuring as well to speak to the guys, because they clearly know their stuff, and they're from an electronic background, include like Ortomarine as well. That's Rob and Caroline's background as well. So we feel like we're in really safe hands.
Yes.
So if you've managed to get through all that, well done.
Yes.
And if you haven't, you're now back in the room.
Yeah. I will now play that video from our trip to Gateshead and to visit Voltsport. Enjoy.
So we're off to Voltsport. It's the company that are connected with the motor that we're getting for our boat. They're also building the batteries for us. They're quite special, to be honest. There's a lot of safety features in them, which we'll show you when we get there, and we'll talk about some of the features.
Yes. So we're going to meet Rob and Caroline from Ortomarine, and we're also meeting Artie and Ruth from Elton Moss. We're booked into a hotel tonight, and we're going to go over to Voltsport in the morning.
We're going for a curry tonight. My favourite food.
Curry's all right. Tasty, but doesn't agree with me. Who else loves curry? Well, we made it to Gateshead and we found a fabulous Indian restaurant just 5 minutes drive from the hotel. Right, let's go inside and meet the team. Rob and Caroline from Ortomarine are inside already chatting to the team from Voltsport. And the purpose of today is to set up a test rig, just to check all the components, or very similar components to the ones that we'll be getting on the new boat. Yeah, so Rob, we're going to have a look at this system in a minute, and this is what we're hoping to get on our boat, isn't it? Could you explain a little bit about this?
Yeah, so what we're hoping to achieve with the visit to Voltsport, who are supplying the motor and the batteries, was basically just to hook up the system as it will be on your boat effectively. And just to demonstrate the relationship between the battery power, the motor power, and then the bow thruster. We've got a small screen that we've set up as a sort of test sheet that we can have a look at. And we've got a small sort of inverter charger that we can demonstrate load out of the batteries. But it should give an idea now of the overall sort of system specification that we've got. We're only testing with 2 batteries. There are another 2 in production. So obviously, ultimately, when this boat's complete, it will have 4 230 ampere hour batteries.
While Rob and the team carry on setting up the test rig, we're going to speak to the CEO of Voltsport, Phil Eagleton. And we asked Phil how the company started.
Yeah, sure. It's we've been going over 10 years now. Back in 2015, like many, had a job, a proper job, and decided that I kind of done as much as I could really do or wanted to do with that particular company. At that stage, I was doing motor controls, software for motor controllers in electric vehicles. So the natural thing for us to do was then to start a business in electrification. So we started, very first project was actually making a power system, a battery system and hydraulic pump system that went into an offshore race boat. So that was a not a round the world boat, but a trans-ocean boat, you would think. So something that might do transatlantic races and fast nets and Sydney Hobarts and things like that. So the original strategy was all very much around doing the kind of projects that other people don't do or can't do, and places where people can't really access the technology. So if something needed to be a bit lighter or fit into a slightly different form factor, we could customize something to make it work for those customers where they couldn't buy something off the shelf at that point.
As we chatted to Phil, we found out that it's not just boats and the marine industry that they supply the systems for.
Yeah, so although in the beginning the focus was definitely marine, I'm a sailor myself, so I enjoy being out on the boat wherever I can. But gradually we realised that a lot of our customers were coming in from the industrial space and the commercial vehicle space as well. So gradually we picked up customers in plant equipment, things like large robotic lawn mowers, wood chippers, pressure washers, and then some hybrid applications in commercial vehicle where we're supplying battery motor systems that go onto the kind of machines that clean drains out. So they have big pressure washers on, vacuum systems. So really, we started to discover that the products we were using had pretty wide appeal across a wide market base, which meant we've been able to do these kind of niche projects. And a niche project for us is maybe 1 to 50 vehicles per year of a particular type. So we've managed to carve ourselves a nice space doing these niche vehicle projects with a wide range of a product portfolio behind us.
And we're about to look at the system that we're hoping to get on our boat. Could you explain a bit about that, what we're going to see today?
Yeah, sure. So we've been putting together electric drive units over the last 5 years or more in this space. So we use a motor family, which is a German motor family from a company called Enduro. It's designed as an industrial motor, but because it's designed as part of a wider family, it means it's general purpose as well. So we've selected motors from their catalogue that suit the low speed, higher torque nature of driving a propeller. We've made units in the 10 and the 20 kilowatt size before. The one which we're trialling here is using a slightly bigger motor, which then extends the thermal performance. So if you want to do more tidal waterways, you'll just have more reserve capability in the motor than previous products have had.
Okay.
So we've got a system set up using the Enduro motor, 48 volt lithium battery with the Victron shoreside services, the Multi-Plus in this case. I think it may be a Quattro for your application, but it's a Multi-Plus on the test rig right now.
Some suppliers of motors and customers of motors focus on the power of a motor. But it's not just about the power, it's the torque and the speed. We asked Phil to explain.
Power, torque and speed are different people like to use a different characteristic. And we see this all the time in all industries where we'll get a request for a 5 kilowatt motor or a 10 kilowatt motor. Our first question that we have to go back with is, what is the speed that you want to run this motor at? Because if it's 5,000 RPM, it may only be a 10 Newton meter machine. If it's 500 RPM, it's a 100 Newton meter machine. So we need to take those true requirements of the application to size the motor. What we do with the motors we use on inland waterways and canal boats in particular is we make sure that we've chosen motors that are happy to run at a relatively high continuous torque for the propeller at a low RPM. So when we're sizing it, we will look at the torque figures of the machine, not the power figures of the machine, which means that you do end up fitting a larger motor, but that means that the numbers we're quoting are the continuous ratings and not peak ratings, which is what you do see across other electric motor manufacturers.
There seems to be a lot of concerns over the safety of lithium batteries, and after the recent explosion on an electric hire boat, we asked Phil about the safety features on their batteries.
Safety in batteries is one where so if you think about the inland waterways and canal boats, it's in a similar place now to where classic car conversions were maybe 5 years ago. There's quite a large number of people who are getting into the space because they recognise that it is the future. But those people that get into that zone do not always have the time, the resources to cross all the T's and dot all of the I's. So the batteries themselves are heavily tested. So the LFP format modules which we use are in themselves, they're crushed, pierced, set on fire by the manufacturer. So we're confident in how they behave in the event of an incident. And it's about preventing those cells from coming into that operating condition where they have an incident. Okay, so you protect them with a suitable box, you provide a suitable battery management system around them. And now that more and more of the integrators are using Victron, for example, means that that's kind of pushing a lot of people on the integration route to do things better. Where we are slightly different to some is that where we come from on the battery basis is traction batteries rather than energy storage batteries. So a lot of the 19-inch rack batteries are really coming from the energy storage market rather than traction. So we've taken an automotive battery management and put it into our industrial products. So we have a higher reliability set of electronics, which we then build that safety on top of. Making sure that the battery is able to isolate itself if it needs to, protect itself if it needs to, because with the best of intentions, there'll always be a corner case you can think of where the charger doesn't stop or the motor doesn't stop. So the battery always needs to be able to look after itself as well. And that's the thing we work very hard on to make sure that that's all done properly.
This is a new boat for us, obviously. We still want to stick with electric. I think some of our viewers are surprised by that. But I think once you've experienced being on a narrowboat and it's silent cruising, early in the morning, birds are singing, you can hear grasses rustling as you go
creep
by.
up on people.
Yeah, you do creep, but sometimes they creep up on you. I just don't think you can beat it. Do you really think that electric narrowboats are the future of boating?
I think they have to be. They are. So in the beginning of EVs, people were super concerned about range. It didn't stop Nissan selling an awful lot of Nissan Leafs, even though that car was very range constrained. But when you use it in the way it was designed to be used, it's perfect. The system that you're building will have a continuous cruising performance of probably, I don't know, April to October without plugging in to charge it up. So then when you realize that you're only a relatively small part of the months where you're going to plug in and charge it as a source of electricity, the cost of running that boat will be significantly lower than the cost of running a diesel boat. Yes, the initial cost at the moment is a bit higher, but I think that cost differential is changing. Batteries have got a lot cheaper over the last couple of years, and I think there'll be a continual trend and a continual pressure on pricing there. And I think the reliability factor and the amount of servicing that is then not needed with the electric one versus a diesel boat means the longer term cost of ownership will come down. If you compare to the very, very beginning of automotive, the very first cars were electric. So Porsche made an electric car back in 1890. It was only killed off because this magic wonder stuff called petrol came along, which was easier to transport than it was to transport batteries. We're now coming back around again to the point where the quality and the capacity and the endurance of batteries is improving, so we can then take over again from the fossil fuels.
We're about to speak to Chris, who's the Chief Technology Officer at Voltsport, and we asked Phil how the working relationship developed.
Chris was actually my boss.
Right.
So he had the dubious honour of me reporting to him. And then after I left Sevcon and started Voltsport, he continued in that role with Sevcon, then Borg Warner, then Turntide. And then more recently, when it became clear he was not going to be working for Turntide much more because new opportunities and things were coming along, I kind of jumped in and grabbed hold and recruited him to come and work with us. So Chris has been doing a bit more of the software development that he's done in the past, and then now moving back into the sort of core engineering and development management and all the rest. So it's really good to have him on board because he's got a lot of experience in the automotive sector as well. So safety and all of those kind of aspects he's very good at, and he's certainly leading the charge for us on certification standards and testing, particularly on batteries right now.
So this is the module that is inside the packs that we're using in your application. There's 8 cells within this pack, and there's 2 of these modules within each battery. And on your boat, we're going to have 4 batteries connected in a parallel architecture. So when we construct them, very simply, you've got the cells here. We've got this cage, and we put the 8 cells in. This is a 8S configuration. That means that each cell is configured and connected up in a series. So you've got about 3.2 volts per cell. 8 of those together gives you about 25 volts as a pack. You can reconfigure these. So we've got what we call a 12 volt version of this as well, where basically you've got 4 in series, but they are then connected in parallel. Lithium-ion batteries, you've got to monitor them very, very carefully and closely to make sure they're operating within their allowed parameters. You don't want to operate a lithium-ion pack outside of its specification. 1, it degrades the pack very quickly, which is obviously not good for the lifetime. And 2, obviously from a safety perspective, if one of these cells was getting very hot for some reason, you'd want a lot of early warning on that. And you'd want to obviously put the system into a safe state and notify the user that was the state. So what we do is we monitor the voltage of each one of these cells. So we can see what voltage each cell in the whole battery has across it. We also have thermistors on this board as well, which are very close to some of the terminals in there. And that allows us to understand what the temperature of this module is. So this particular design here has 6 thermistors on that, so we get very good coverage of what's actually going on within the pack. And then there's a little kind of microcontroller on here, which is basically taking all this information and it communicates that down a serial comms bus to the battery management system. And the battery management is basically the brains of the pack. That's what's handling the whole battery operation. That's what makes it all safe. So we've got the bus bars here, and these are actually flexible bus bars. So a typical bus bar is literally just a metal bar, but these actually have these flexible components in here, and the reason is under vibration, and even when compressed in this way here, you can still get a very small amount of movement on that. If you had solid metal bars between these terminals, you'd be putting a huge amount of stress onto this here. If you imagined 2 cells side by side, and they were trying to slightly push apart from each other, even though you're talking infinitesimally small distances, that is actually a lot of stress going onto that terminal. And that's simply using these flexible bus bars takes a lot of that away. This is the isolation contactor that we have within the batteries that we're using on your boat. And very simply, each of the battery enclosures has one of these inside, and when the battery's powered down, or if there's a fault with the battery, this isolation contactor is opened, and that isolates the battery from the rest of the system. We do obviously, the battery management system will also transmit error messages over the CAN communication network, which can then be picked up by something that should be monitoring that in the system, and then indicate to the user there's a problem there, and you need to get the battery looked at and serviced. So this is one of the safety features that exists within the pack, but there are lots of other safety features in there as well. So this is the battery management system. So each of our battery boxes that we've got next door has one of these in it, and you can see there's a lot going on there, but there's a lot of things going on to handle a battery. There's more on the battery than just actually the cells. There are other features in there as well. So for example, we've got some relays in here which can be used for various features and functions. You've got a lot of measurement going on. So we use a Hall effect sensor to measure the battery current. That has to interface with this battery management system. We've got various analog inputs and outputs and some contactor drivers and so on to control this. And then of course you've got the microcontroller. So this is the microcontroller here. This is basically the brains of the battery. So this takes the information coming from this board and it makes sure that this pack is operating within its operational limits. If there's any issues, it can do things like output warnings onto the communication network. And if the state of the battery gets to a kind of a more critical state, it can deactivate these or open this and isolate the battery at that point. Okay, so we've basically got just a small test screen here that we've set up just to prove and establish communication with the main motor drive. So it's just basically showing us RPM of the motor, battery voltage, battery current, etc. And then we've got a few other torque variables coming through. But it just demonstrates now that we've got communication with all elements of the powertrain.
This is the N-gyro motor that we were talking about earlier. It's very similar to the one we've got on our current boat. That's the bow thruster, and here are two of those batteries built by Voltsport, and they're just testing the motor at top speed.
So what we've basically got here is it's a similar motor to the main drive motor, but a smaller version, runs a lot faster, but it uses the same controller manufacturer. So everything is networked together quite seamlessly. The integration is there for us to allow sort of remote control, fixed control, joystick control, all from the same machine network.
Voltsport and Ortomarine have been working together now for a few years, and we asked Phil what the benefits were for everybody involved.
It's definitely great to see that the guys at Auto we've been working with a number of years, 4 or 5 years, something like that, and we've over that time been able to build up a strong relationship of not only us trying, sometimes we get it wrong, but mostly understanding what the requirements are, but also Rob and the team at Auto being able then to take what we give them, implement it, and feedback things that help us make it better for the next customer and the next customer. And that's very much what's happened in this case. Is there's been a number of projects over the last couple of years where we've just worked with Auto in the background to optimize and improve and so every boat is better than the last, effectively.
Well, Phil, thanks so much for talking to us. I know you're a very busy person. We're really excited and looking forward to having your products on our boat, and we can't wait to see how that boat performs.
So we can't wait to have a drive.
Come out and give it a test drive.
Yeah, we'll bring the Smart Roadster, and we'll.
Yeah.
You can take that for a drive.
Yeah,
And I'll take
you
the boat. For a drive.
Yeah, you're very welcome to.
Really hope you found that interesting. I know it's like quite a lot of technical stuff to take in. Some people love it as well, and some people it just goes over the head. But I hope you enjoyed it. We found it interesting, didn't we?
The fact that they build their own batteries there and they've been going for 10 years, Voltsport, we feel very confident that we're getting a great system now, don't we?
And it's going to be custom to our needs as well, which is quite important, I think.
Yeah, and feel confident on the rivers as well, which will be good.
Yeah. We're hoping to do the river link as well. We did specify that, didn't we? So yeah, we're hoping that the setup will be able to cope with that, but we'll find out.
Yeah, we can't wait. I'm sorry if I'm slouching and falling off the dinette, but Sebastian's taking up most of it, isn't he?
Well, he's more important.
Yeah, he is. It must be very warm. I'm roasting. But we hope you've enjoyed that video. I'm going to go over to the factory in the Czech Republic this week and do some more filming. So we shall show you that in a future video.
Yeah, hopefully there's been some significant sort of movement on the boat build. Yeah. So we hope to be able to show you that.
Yeah.
We're hoping, fingers crossed, that the parts are over and Rob is going to do the install. Yeah. And you can film that as well.
Well, thanks so much for watching. If you've enjoyed this video, don't forget to give it a like and
keep your comments coming. We receive loads of comments, don't we? We do try to reply to every single one personally. Yeah. It might take us a few days, so bear with us, but we do like to receive them and read them.
Yeah. And can we say a massive thank you to all those people that bought us a coffee and our patrons and our channel members. And we're going to announce, I think we'll do a separate video and announce the winner, because every month we're going to do a draw for our patrons, Buy Me a Coffees and channel members to win one of my A5 prints from my artwork. But yes, we better go and do some packing. Thanks for watching.
Take care.
See you soon.
Bye.
Bye.